Welcome to PowerShell Wednesday. Every single Wednesday at 2 p.m. Eastern, we are live with a PowerShell session. Most of them this year are going to be beginner focused because I noticed that that is a large area that needs some attention. There's lots of folks that are looking to learn PowerShell, and we're trying to make it easy for you. And one of the core things that you're going to run into in your PowerShell journey is functions. And initially for me, I thought functions were really fancy. Like I could put together a couple lines, maybe I changed them from the internet or whatever, but to turn them into reusable tools was a different story. So fortunately today, we have one of the most prolific PowerShell module authors and tool makers that I know of. There's a couple who are up there with him, but Fred has an amazing, amazing tool suite. Maybe he'll tease it a little bit today, but he's going to show us a 101 on PowerShell functions.
Well, I am doing most fabulously fine. I get to talk to other people about PowerShell, and I love talking about my favorite hobby. I'm this kind of nerd person who just loves talking about his key interests. And in most social settings, that's a bit of a problem because it's his key interest, not everybody else's key interests. But thank you for gathering all the other people that actually do share that interest from me. So I'm not even being not obnoxious today, hopefully. We'll see how well that works out. Well, as you pointed out, I'm kind of doing lots of modules, lots of commands in PowerShell, and functions are kind of the key building block for building reusable tools. So I'm writing one heck of a lot of them. It's a topic near and close to my heart, and I could speak for hours on that particular topic. Unfortunately, we don't have hours, so I'm kind of needing to focus on a few key interests, key points. So we're going to go down by priority. Time is going to run out before content is going to run out. So we'll have a good PowerShell time. Getting started with the very basics and taking it from there. The key goal for me today is to ensure everybody watching this is able to do functions, able to understand why we do want to do those functions, and as far as I get, the super magic powers we can lend to functions to make them even more awesome. So before we get started, really digging into things, we're going to start at the very beginning. Like, how the hell do I do a function? It all starts with the function keyword. Then we assign a name. This could be whatever. And then we put in curly braces, and everything inside those curly braces are PowerShell statements that will be executed when I call that function. We'll be coming back to that in a moment. First, I need to fix one particular thing. This is not a good name. This is actually a pretty atrocious name. We need to name our commands or functions, the things that we need to give it bit of a useful name. There's a huge list of naming snafus in the history of PowerShell. So there's two key takeaways from a naming perspective. Verb -none. I'm going to remove an item. I'm going to create a new AD user. I'm going to search a command. I'm going to, whatever, I've got a verb. What am I going to do? And a noun, what am I going to do that to? Basically, whenever I run a get command, I want to be sure that I want to have the confidence that I'm not going to break something. And in PowerShell, that actually works. So there's a list of verbs that you're supposed to be using. Best try to stick to that. And well, that's a long list. There's an explanation. We're not going to delve too much into that. Just figure out what's going to work for you naming-wise. But I'm going to go with a very classic one. I'm just going to write a hello. I mean, we all start programming with hello world. And write is the closest verb we get in PowerShell. So the second key recommendation on the naming part, when you're trying to name a command, don't name it for the technical steps you're implementing. Name it for the logical steps the user is trying to execute. If I'm trying to connect to a service as a user, I want the command to use connect service. I don't want it at session cookie. That's not the name the command should be having, even if technically it's the correct thing what it's doing. do it by what is the user, and that user is most notably going to be your future self half a year down the road with no memory of what you wrote there. I'm definitely not speaking from personal experience here. Just think like, what's that person trying to solve when they're trying to find my command? So we now have a function, and we can put things into those curly phrases, 1 line, 10 lines, 100 lines of code, 1,000 lines of code, 10,000 lines of code. There is no size limit. PowerShell is going to execute it 1 line by line until either an error happens or it's complete, which is kind of the problem with computers. They do what we tell them to do, not what we meant to tell them to do. Slight differentiation here. So I'm just going to go and say, hey, hello world. And then I'm just going to run it. So first, let's grab that function. And if I actually, use the correct command, this is actually going to work. Typos, my eternal nemesis. Nice thing, once we have run this function definition, you might notice that it's not writing hello world on the console when we're just running the function definition. At that point, PowerShell just registers the command, and then we can use it. And I can call this as many times as I want. Pretty nifty. Now, there is one key learning to take away from this whole thing. PowerShell is a scripting language, yes, but it is also slightly different, especially if you're an old Windows person and you learned your scripting with Batch and Visual Basic Script, which is hopefully into the past, but they're not the only languages where that's happening. So here's another key thing to keep in mind. If we define our functions, and do it like this, there is going to be something fairly ugly going to happen. It's called red error messages. Red stuff on PowerShell means something went wrong. And the key thing about those messages is to actually read them, which surprisingly often people forget, especially when we take out an older version of PowerShell, like the Windows PowerShell, which is less friendly when it comes to error messages. Key thing here, we have an error command not found, because PowerShell does not pre-compile the entire script. It doesn't scan the entire script for where's a function so I can pre-register it and then use it. So this is something you'll be seeing a lot in PowerShell scripts. First come the function definitions at the top, and then the actual script execution that's calling the functions must be below that. If that's a bit more confusing still, don't worry, we will have live examples of entire scripts using functions fairly soon. So, yeah. That's something we need to do. So we have a function, and we can make it do things. I mean, I'm all in favor of doing things. Doing things is great. But sometimes we need to be able to tell a function what to do. Just imagine the command remove item. It deletes something. What is it going to delete? If we can't tell that to the command, it's going to be fairly single use, pointless, or highly risky, depending on how you implement that. So we come to parameters. Let's see what we can do about parameters. Parameters enable us to provide information for a command to do things with. So let's go ahead with write greeting. And now I need to be able to define parameters, one or multiple. It all starts with a param, open parenthesis, and closing parenthesis. And then I define the parameter as a PowerShell variable. It starts with $, and then comes the name that we want to provide to the parameter. Now, I'm not going to do anything. There's no code happening here for now. I'm just going to send write greeting and define it. And now you can see it recognizes that parameter name since I defined that. So it works. We didn't get an error. It didn't do anything yet since we didn't do any actual implementation. We didn't do PowerShell statements. We didn't do nothing. So what can we do? We now add that. Let's go with write host. I'm going to use the parameter value as a variable. Since I defined this in the parent block, I can now, inside of my function, access that by using it as if it were a regular variable. For all practical purposes, it becomes a variable. So, didn't work. Key part when we write PowerShell functions. Just because we modified the function doesn't say PowerShell knows we changed that. PowerShell does not automatically sync the content of our script files into the console just because we ran it once. No. The only way to do this is we need to run this again, redefine the function, and then we're good to go. And now I can provide different names, and I'm getting your greetings. Could be doing that a bit better. Now, that works.
Fred, can I emphasize something? Because I think this is such an important thing. So parameters, like we're seeing here, it's just a way to modify what your code does so it's a little bit more reusable and portable. And I think the other thing you said was defining the function, right? Redefining the function as you go. For me, using that word of define is really helpful in understanding that it's literally what tells PowerShell what it does. There's no inherent magic there. But I'm loving this demo so far.
Thank you. So that's great. So far it works. But there's one issue I have with this whole write host here. Write host tells PowerShell paint on the console screen. The data is lost. Quick example. I'm trying to store the result of write greeting into the variable $result. Didn't happen, or at least it's still printed on screen. And if I now try to access that, that didn't work. So what can we do? We can remove the write host. If we just provide the string, now something interesting is going to happen. I, again, need to redefine the function, otherwise the change won't apply. Now, if I just execute the command, that works. But now I can store the result in a variable, and that means I can now reuse whatever came out of our function. We will later look into a lot more detail on handling output and what the hell is happening here. So don't worry, this is just kind of an introduction into the key capabilities. So that's pretty much that. We have the output, and we can now do things. We can provide information, and now we just need to write our script. Write a function, implement what it is actually supposed to be doing. The absolute core basics. So the next question, one of the key questions, I believe, for learning anything really, is why the hell should we be doing this? What's the problem I'm trying to solve? What's the benefit I'm trying to gain? And I have a few examples that are going to try to visualize exactly that. Why the hell are we here and dealing with functions? There are essentially two key usages really for functions. One of them is to make code reusable. If I need to write the same 10 lines of PowerShell snippet 20 separate times in a script, I'm going to have a lot of duplicate code. And if I need to change that, I need to change it in 10, 20 separate locations in my script. So that's for one of the key usages. It takes it one step further because at some point we get reusability, not just within our script, but across multiple scripts, which at the far end of that journey ends up with us writing PowerShell modules, providing reusable packages, not just for ourselves, but also for other people. And the other part, and that's another one that is very dear to my heart, it makes code a lot more readable. This is kind of an abstract benefit right now. Don't worry, I have a great example on how we get that readability further down in this chapter. But let's start with reusable code. Now, one of the things I have extensive tooling for is logging. So this is one of those, yeah, it kind of works, but it's crappy kind of approaches to logging. And that is me just using add content to add more to the log file. This is, no, please don't do logging like this. Save yourself the pain. So we start with set content. So we discard everything from the last log cycle, and then we add line by line by line. We call a function, which again is trying to write to the same text file. As you can see, this is a bit annoying. We need to provide a path every single time. We might want to store this in a variable and only pass in the variable, but still, it's annoying. If we execute this, and what's up with this line, we'll be getting into a bit. We now executed the logging, and if we take a look into this file, that's exactly what happened. This works. It's okay. What's wrong with this? Well, other than having lots of text duplication, it makes it really, really hard to improve the logging. Because if we want to extend somewhere, we need to extend or modify or make it better in every single line that's doing this. Just for example, in this logging, it would be nice if we had a timestamp at the beginning. That's pretty useful. Another common thing for logs, how about a status code? This is an info message. This is a debug message. This is an error message. All of that would be nice to have, but making that happen without fundamentally changing how we do this, that's going to be a lot of effort. So yeah, that's the problem we're trying to solve here. So let's look at a second approach to logging. Now there's some black magic happening, but that's okay. You don't actually have to understand that. This is again the same thing other than that we're using a different file path. In this case, since I extended the logging quite a bit, you now specify at the start, where do you want to log? We never again need to touch this path. And at the end of the whole thing, we need to stop log. And that's just sending log messages. We can add additional metadata like tagging, specify a target, specifying error message. We might even be able to provide different status codes. It's easy to extend. For example, at no point do I specify a timestamp here. But if we execute the thing and take a look at this, you can see that there's a timestamp in every single log message. This is now a CSV format. I can automatically parse that and monitor the log for errors. I have a lot more features in there, which is something I can afford to do because all I need to do is I need to add this at one location here in write log. By modifying the content of this one function, I can make everything better, every instance where it's being used. So I only need to do it once, and bam, every single log message, every single log has been improved. And since this is a function, a dedicated command, I can now copy paste this into another script, and I get logging in that script as well. I only needed to implement this once. And in case you're wondering, yes, everything that you're seeing here on VS Code is on GitHub. So you can access that. And if you don't want to implement your own logging, you can copy those functions. So I wrote the functions, you can use them. So even a better way to be lazy. It's great to build tools for make your code reusable, to make it affordable to invest in good feature and good code quality. Because if you only have to do it once and it sticks, well, that's a lot easier discussion with your manager why you should be investing that time. Otherwise, it's, well, your coding just has to be good enough to do the job, and that's it, nothing fancy, nothing high quality, because you can never do the justification. But if you build tooling and save time down the road, that's an entirely different conversation.
I think, Fred, another added benefit of this approach is when you teach other people on your team how to write things, like you take the barrier away from them. They have tools they can get started with. You have an approved way or a generally accepted way in your organization where you write the log files, and then you know what to look for instead of having like 3 different people writing PowerShell, all with their own log methods. And then you try and update the code and it's just a mess.
Absolutely. That is one of the absolute key benefits, both in scripting in general and functions in particular. It basically allows us to encapsulate our knowledge, our skills, and hand them over to the next person without having to do it for them. It's a force multiplier, really. So, reusable. Reusability, great argument. There's a second one, readability. Now, take a deep breath, harden your soul, harden your mind, brace yourself. This is going to be ugly. Actually, it's not horrible. The script I'm going to show you is mostly what happens when people teach themselves scripting all on their own and never really get this brainwashing from me, like write functions, write functions, write functions. This is how you should be designing your scripts or something like that. I try to tell people, but I can only reach that many. And if you are stuck on your own, teaching it to yourself, well, you just make it work. And the script works, it's not bad. We are not going to go through this line by line by line trying to understand this. Don't worry, this is for a quick impression. But basically, after a quick header, we ensured that we're running as administrator. Not the best way to do that, but it works. We disabled TLS 1.3 and all the older versions. Moving on, gather some information, do step-by-step loading resources, reading credentials, having some commented code in case we need that at some time in the future. Spoiler, we don't. We actually do have some functions that do some bare bones stuff. Let's ignore that for now. So we have a few functions in here. Not too many, but a few. It's great, better than none. Then we call us function and ask them how do we want to operate. And depending on the input, we either prepare to read a text file or we ask the user for input. We pause the script in case a coffee break is warranted and we don't want to be kept in suspense. And then we either use the manual list or we read the explicitly provided text file of the content. So far, we've gathered a list of virtual machines. And then we do something with that list. If we have a list, we resolve that with getVM, complaining if we don't find the VM virtual machine. And after that, we deduplicate, write some messages with write host on a screen. And for each virtual machine, we collect a lot of data, don't care about the details, and prepare printing that on screen as well with more different questionable techniques. But we go line by line through the whole thing and present more information. And at that point, we have some more commented out code, and we're good. Now, of course, I pushed you in fast, extreme fast forward through more than 500 lines of code. I sincerely hope nobody of you actually was able to track what the hell is happening here. That wasn't the point. Basically, if you want to understand what the script does, we need to start at the first line and then go through the entire script line by line by line, just to understand what's happening here. It took us 300 lines just to realize we were collecting a list of virtual machine names. That's what we did the first 300 lines, and it only became apparent at the end. If later at some point the script has a problem and we need to debug it, and we get an error message and, oh, exception happened in line 403. We first need to read the entire script to figure out what happened here. This is a lot of effort we need to do as an overhead just to get started. So let's do the same thing again in significantly more readable. More readable does not mean it's shorter. Actually, it's longer. But other than having introduced some parameters and better documentation, thanks to functions, this now is the entire workflow of a script. If I need to figure out what the script is doing, I need to read that highlighted block. All of these functions in there are stored in that region. As you can see, that's about almost 500 lines of PowerShell code that I'm hiding. So there's a lot of code there. But if I now later, half a year, an entire year, 2 years later, need to figure out what the script is doing because monitoring suddenly started to fail, well, I need about 5 minutes to figure things out again. I might not know all of the details of how I did things, but I can figure out what. What's the purpose of the script? What's it trying to do? What are the high-level steps it's trying to do? And then I can drill down into where the hell did the error happen? Why the hell does this start failing? It makes coming back to my code a lot more enjoyable. So yeah, make stuff readable. Now, if those 2 examples caught your interest and you want to know more about my approach to designing scripts, which involves a lot of functions, I have a conference talk on that, and the link is here. I'll, of course, be including that in the GitHub and try to share the link around. So if you want, like, have a dedicated hour on script design, that's your address. We unfortunately need to kind of diverge because our focus for today is functions, and I've already eaten half the time. So functions, they're great. So we need to talk about scripts. Why the hell scripts? Well, functions are basically pieces of PowerShell code that we call by name. Scripts are pieces of PowerShell code we call by path. And really, it's pretty hard to get a function without having first loaded up a PowerShell script file. So we need to talk about how to run PowerShell script files to make this work. So let's do some generic script calling. And leave it at that. Just some random list of PowerShell statements. Child item under C. Nothing suspicious there. And by having that in a script file, PowerShell script file and on .ps1, The one, because at the beginning, when we invented PowerShell, we kind of assumed that we wouldn't get the language quite right at the beginning, and we would be needing a version 2 or a version 3. Didn't work out that way. Turned out there was lots of foresight involved, and this whole thing worked out well enough. But, well, we're stuck with the extension now. Now, what this ampersand is doing here, we're going to talk about that in a minute. But first of all, we can just run this code, and whatever we wrote in there happened. Pretty great stuff. But there's one problem, and that happens when we start on a new computer and we're trying to run PowerShell, and we're trying to run scripts, and that is called the good old execution policy. Now, what's the execution policy? The execution policy is a feature that restricts how exactly you can execute a PowerShell code. So I have prepared a slightly constrained console here, and the following error message is what most people are going to encounter when they first try to run PowerShell on a new computer, and we're just trying to get started on the whole thing. This file cannot be loaded because running scripts is disabled on the system. Now, there's a command for that called get execution policy. And we can see it is set to restricted. If you're using the -list parameter, we can see that this execution policy can be defined at separate levels. And the first one that is not undefined wins. And if all of them are undefined, well, guess what? You can't run PowerShell. So you can see the first one is at the process level. I totally set this up just right now. And I can lift that by switching it to remote signed. Remote sign says scripts I wrote are fine. Scripts that come from the internet are questionable and should probably be prevented. Doesn't mean you can't copy paste from some GitHub sample into your own script. So we're not gonna go too far into execution policy, just enough to figure out how to unblock ourselves. Execution policy is something some people consider a security feature. If you care about how the hell do I secure PowerShell, there's, again, another conference recording where I talk about that part, so follow up on that if you care more about PowerShell security. So we've got scripts. We now can store our PowerShell code, so we can store our functions. So let's go ahead and check out this nice little function. This is a function that I just put in the file, and I now want to include this file in my script. I can't put everything into a single file, but if I want to share, for example, logging amongst multiple scripts, it might be useful to offload that into a central file I just include in all of the other files. So that's the plan for get random number here, because that's a fairly easily understandable function. The parent block, we're going to talk about commanded binding later, possibly. But it's a simple function, gives me a random number between 10 and 99. So let's run this script. Unfortunately, since I have a fairly lengthy name, I put this into quotes like this is a string. PowerShell didn't know I meant to run this file just because it happens to include a path to a script file. It's a piece of text. If we want to tell PowerShell, this is actually PowerShell code I want to run, this is a command, I can provide the ampersand. The ampersand tells PowerShell whatever is behind the ampersand is a command executed. So that's what I do. I executed the file. Not much to see there. I mean, we only define the function, we're not calling it. But theoretically, we should now be able to call the function. Didn't work out quite the way I had hoped. What's happening here is when you run a script or function, PowerShell executes the actual code within that script, within that function, in a kind of sandbox. Technically, the term is scope, but let's consider it a sandbox. Everything that happens in that sandbox is isolated within that sandbox to a certain degree. And when a command or a script is done, we discard, remove everything inside of that script or function. We do that for several reasons. One of them is if we didn't do it that way, PowerShell would keep all the variables inside of that script in memory all the time, so we would never release memory until we close the PowerShell console. This would, depending on how much RAM our machine has, lead to a slowdown or a complete breakdown of PowerShell. So we don't want that. But if PowerShell is going to discard everything that's in that file once we're done, that makes it really, really hard to use include files to offload our PowerShell code into separate files. So what we do here is something called dot sourcing. Instead of the ampersand, we are using the dot. The dot acts exactly the same way as the ampersand. Whatever you place behind the dot is a PowerShell command executed. The key difference is the dot operator tells PowerShell, don't run this in a sandbox. I want to keep the content. And if you do that, voila, our random number function now properly works. So we can dot source include files into our console, into our script, if we have another script. So how do we do that? There's one more problem here. And I'm going to show that problem. First of all, problem one, before we get started on that, if we need to provide the full path to the file, that means for a scripting solution, we need to tell our coworkers, place all of the script files in exactly that location or a script is going to break. Which means most of your coworkers are going to have problems because they don't read the manual before they're trying to just run the stuff and see what happens. So that's not good. Let's see a second problem. And for that, I need to create a couple of sample files, script 1 and script 2, and I'm going to add more text content to that. This is mostly so people can reproduce this easily. Let's take a look at what's happening here. Script 1 is going to execute a byte host and it's going to print on screen, hey, yeah, this is my current file was executed. And then I execute /script2.ps1. I'm doing a relative path to the second file, which basically prints, hey, script2 fired. Simple enough. So let's execute it and see what happens. I'm pretty sure that's not what's supposed to happen when you run the script. So something was iffy with this line. Yeah, problem. This is a relative path, but it's relative to what? Relative paths are great, but yeah, in PowerShell, relative paths are always relative to the console, not to the file. So script1.ps1 is somewhere in my GitHub, And this, dear file, is unfortunately somewhere else. It's in my demo folder. And I totally by accident, I definitely didn't plan that for the session, accidentally placed some other script 2.ps1 that happened to be the same name as the one that I'm executing here. So if we want to work with include files, we need to figure a way around this. There are separate approaches. We could figure out what our current path is somehow and change the console path and keep calling relative. Changing the console path is strongly discouraged because if the user cancels our script Control Z, we would keep the changed console path rather than where they were before. We could, as part of instruction, tell everybody, okay, sure, just unwrap the zip file with my script files, including the log.ps1, but you need to run the console from exactly the same folder as the files, so the relative paths are correct. We can do that, but it's bad. We don't want to do that. Don't make me sad. What we can do is something funny, and that is a system variable called pscriptroot. Pscriptroot is the path of the folder the current file is in. So when you have a script file that you're running as a file, $pscriptroot points at the folder the file is in. So now we are looking for script2.ps1 that is in the same folder as script1.ps1. And voila, that's it. So we've got that. Let's see what we can do about making this work the exact same way. Remember the logging script we did? I've got the script is for sample logging. I've got 3 functions with the logging part. So let's do that. Logging.ps1. We could give it some prefix, something like lib-logging.ps1. And I might want to make a copy of that. Copy item. So anybody looking at the materials can work that through. So we have the logging here, and I'm now going to steal that out of here. So now we have lib-logging.ps1 in a separate file. We no longer include the logging in here. And I'm going to .source this into the current script file. So that should have worked. And we can now execute it. After I remove the log file that we'll be creating. And if we take a look now, we created the same log file again. So this configuration obviously worked out. And we now have a dedicated library file for our logging features. We can now include in multiple scripts and just use the functions. So,
Fred, could I ask a question real quick?
Sure.
You covered it briefly, but can you go into the differences between the ampersand and using dot and why you would use one over the other?
Sure. Basically, the dot is when I want to keep whatever is in this file. Because with the dot operator, we call the file not in a sandbox, not in a dedicated scope, we call it in our current context. So if I want to keep variables defined in that, or if I want to keep the functions defined in the script, I need to dot source it, because with the ampersand, it's all going to be gone. It's just going to be deleted at the end of the script file.
Yeah, okay, that makes
now,
sense.
why do we not want to do this all the time? The thing is, let's say I've got this huge script we previously saw, my example nightmare script. That script is going to define a lot of variables. And I don't want to have to read all of that. So let's say I have a console, my terminal window, I've run some commands, stored some information to reuse later on, and then I call that script with the dot source operator. I might accidentally have that script override my variables because it's run in the current context. So they collide. They're happening in the same box. But if I call with the call operator, there is no conflict. Everything happens. Everything that's placed in that script happens inside of that sandbox. And if there's some collision, it doesn't matter. Once the script is done, everything in the script is discarded, and my console remains as it was. The only thing we keep from that script is any output produced. So this isolates it, which in case of unknown code, where we trust it's doing what it's supposed to do, but we don't know the details, is the go-to. It's just safer. And it prevents a memory leak.
Awesome. And your description right there helped it click for the person who answered or asked the question. So thank you for
Excellent. Always happy to. I mean, that's what I'm here for. Talk about PowerShell stuff.
Yes, sir.
All right. Moving on. With a look on the clock, this is probably going to be the last chapter. Apologies for anybody who wanted some of the more unknown chapters you don't know about, because I totally did not spoiler it in the link. All right. Parameters. What can we do with that? How can we provide information to a function to actually make it work differently, make it work specifically to the situation that we have in mind? That's where parameters come in. So let's do that. I'm going to define a function called writeGreeting. I'm going to give it a parent block, and there's a name. I'm going to create that. Works well enough. We already saw that at the beginning when we looked at how the hell do I define a function. So that's cool. It works. But currently, I can also just not provide anything. And as you can see, the greeting is kind of lackluster. Might be a good idea to somehow provide a default value so we don't accidentally have nothing here. So how do we do that? It's fairly simple. I assign a value. As if I would assign a value to a regular variable, I can do that in the parent block as well, mostly. If the default value is a command, put it into parentheses. That's the only thing. So if it were a command, do something like this. So we redefined the function with the default value. So I can now provide the name, or I can just not do it. That's useful.
So, incredibly useful. Can I just give one little tip here? Because this is such a big thing. If you're writing scripts and you have variables that you define, I highly recommend considering putting them in a param block with a default variable so that if people need to change it, you or someone else in the future, you don't have to edit the script. You just change the parameter. But if you don't need to change it, you just run it as normal and change the ones that you do need to change.
Absolutely. And by the way, thank you for bringing this up, Andrew, because there's a big spoiler. I need to come back here. we're in the chapters for parameters. I previously said, and probably was lost in all of the other flood of words because of my personal verbosity, that a function is a piece of PowerShell code that we call by name. A script file is a piece of PowerShell code we call by path. Everything you see here about parameters that we're doing with functions also applies to script files. It's the same mechanism behind the scenes. So, sometimes we have write greeting, we have default values in the param thing. So let's screw something up. You know, I'm a human being, and there's this one thing all of us fear. When you do programming, it's called a typo. Oh, that worked. This parameter does not exist. You can see it wrote hello world. It simply ignored the values I provided here. We didn't get an error. It didn't tell me I did something wrong. No, it just did its thing and ignored the incorrectly provided values. This is a bit annoying. Personally, for me, I would prefer PowerShell to complain about unknown parameter. I don't want it to silently ignore me, especially when I try to change something that has a default value and it will just work just not the way I had in mind. So there's a way around that, and that's kind of important. When you have this param block here, there is one golden rule to keep in mind. There can be no code, no script code above it inside of the functions. All the statements like this hello here need to be below the param block. There are a very few exceptions to that, and one of that is something called the commandlet binding. The commandlet binding is a black magical tool that provides a lot of features we are not going to talk about today. But what it does, most notably here, is it enforces that all parameters must exist. As mentioned, it can do a lot more than just that. Look it up if you care, but mostly it pretty much never hurts and makes sure that if you have a typo in your script on the parameter name, PowerShell is going to complain rather than doing the unexpected. So strongly recommended, whenever you use a param block, use a commandlet binding. Moving on, there are a few more things we can do in the param block that's worth mentioning. One of them is I don't want to provide a default value. I want to make this parameter mandatory, that it must be provided. Now, if you're wondering how the hell did I type this that fast, I built a snippet into Visual Studio Code to accelerate my typing. Again, we need to redefine the function. Otherwise, PowerShell is not going to know. But if I now execute write greeting without providing a value, the console prompts me for the missing values. If I remember to provide that value, it doesn't ask. This interactive prompt only happens if we have an interactive user session. If this happens in a scheduled task, your script fails with an error, which should lead to the task failing. Also note, this here is optional. You can just leave it as mandatory, and that's fine as well. So, moving on, 2 more items.
So Fred, someone asked a question.
Sure.
They said, why did it turn into an interactive session? That's because the parameter was mandatory and you didn't provide it, so it asked you to fill it out, right? Just a built-in feature.
It's a built-in feature that happens if the console is attached to a Windows or Linux user session that has an interactive desktop. The fact that this PowerShell console here belongs to my logon session with a full desktop means I get a prompt. If it was running as a scheduled task, a system, for example, there's not an interactive desktop session, so it just fails. But yeah, as soon as this mandatory flag is there, it will prompt for the value if I don't provide it.
Which is, it would take quite a bit of code that you'd have to write to do that yourself. But instead, you just put parameter and then you add the mandatory attribute to it and you're good to go.
Exactly. Makes it a lot more convenient. So, two more. Expected types. It's usually a good idea to define what data type you're expecting if you know what data type you can get. For example, if I let's do something fancy. So I'm going to call the method substring on string, and I'm not going to do the type. Let's first do something weird here. Now, this is supposed to work just fine, and let's see how that works. So it provides the initial in addition to the full name. Great stuff. Problem. What if I don't provide a piece of text and instead a number? That is suboptimal. Because the method here is type specific, $name is just whatever it is. So if we need a specific type, it's usually a good idea to tell PowerShell this is supposed to be a string. And if we tell PowerShell this is supposed to be a string, then PowerShell will make sure it is a string. So, highly useful. One more important one that I kind of forgot in the notes. We always had only a single parameter, a single value that we're providing. What if we need multiple values? So let's go ahead and do that. I've got surname and I've got a given name. Now, important part about the mandatory thing, we need to specify it per parameter. And if you're providing multiple parameters, the first squiggly thing here tells us where the error happens. If we have multiple parameters, we need to separate them by a comma. Technically, I need to be able to stuff the entire parent block into a single line. It's just too much of a bother usually to do that. It's hard to read. Imagine all of that would be in a single line. Nah. So let's change up our output a little bit. This PS custom object thing is nice magic. We won't be talking about that today, unfortunately, but it's something to keep in mind. And maybe look up later. So we now support multiple parameters. If we don't provide them, since both are mandatory, it's going to ask me for both of them. If I provide them all, it just works. And if you're wondering why we have this nicely colored and styled tables, that's where PS custom object comes in. Absolutely awesome. So we need one last one, because it's a nice capability. And that is mutually exclusive parameters. So let's say I have one more parameter, which is the old name parameter, which is mandatory. However, I only want either surname and given name or name. I don't want all three together. They should not be combinable. We can do that by providing something called a parameter set name in the parameter attribute. So this parameter thing, it can contain more than mandatory. The parameter attribute, this controls the behavior of this parameter. And by providing it with a parameter set name, we can now make them mutually exclusive. Either you provide name or you provide surname and given name. And if we provide one more parameter here, which is optional and not part of a parameter set name, then you can always provide age irrespective of which of these sets are active. So this works, and I can provide an age, or and that works. Casing. I'm kind of OCD about casing, sorry. We can still provide an age, even if this is probably heresy with a female name. But this now is not going to work. They cannot be combined. Either pick given name and surname or pick name. Don't try to pick both. If you want to take a look at the options available, you can analyze a command by using get command with dash syntax, and it shows us the legal parameter combinations. All right, last one, last riddle. What happens when we now just write greeting without any parameters provided? Oops. This whole mandatory thing stops working because PowerShell needs to be able to resolve to a single parameter combination. That's legal. One of these so-called parameter sets. If it cannot agree on a resolve to a single one, it fails. So, fortunately, we can do something about that. And that is, this commandlet binding is to the entire command was the parameter attribute to the surname. The commandlet binding controls the behavior of the overall command. And there is an option here called default parameter set name. This acts as a tiebreaker if, well, PowerShell can't decide what's the correct parameter set. And that works. All right, parameters 101. We can do a lot more, but the clock has ticked, and we are pretty much at the end of the road what we can reasonably cover here. But, well, I don't know, Andrew, maybe we can continue this another day.
Can I ask one more question for you to show something else?
Absolutely.
So that's input validation. Can you show like validate script or some of the ways that we have built into PowerShell that we can validate our input, make sure people don't hack us?
So I've got this function prepared on the topic. This is a classic log rotate function. It accepts a path, how many days retention we want, and whether we want to remove everything or only remove files or only remove directories. And that's going to do its magic and it's going to work. So what I'm going to add in more one message so we can see what's happening here. So this is nice. I'm going to provide ctemp demo, and I'm going to, I only want to remove files. Okay, yes, you're correct. So, nice type, only problem is this parameter accepts all file or directory. You just need to validate that somewhere. We could do that inside of the function with an if condition, but there's something pretty awesome here. We have something called a validate set, which allows us to specify what are the legal values. And if we do that, we gain instantaneously two major benefits. Benefit number one, providing the wrong value gets punished immediately. It doesn't just do nothing. It's going to affect it. It's going to do validation, but we tell PowerShell what are the legal values. And if we tell PowerShell what are the legal values, PowerShell will tell us what are the legal values in return. So we get tab completion, we get IntelliSense. So that's validation number one. Validation number two I've prepared here is for max days, because currently I can tell it, please delete all files, max days -14. Which it did. Looking into the future for log rotate is, well, prescient, but probably not practical for the problem. So what we have here is something called the validate range attribute. The validate range wants a minimum value and a maximum value. I'm supposing 2 years log retention is enough. And if we do that now, PowerShell will tell us what the limits are the moment we exceed the limits. So last one, path. I can currently provide a pretty bad path, And as you can see, PowerShell the function started executing, and only when I reach the line where I'm trying to actually access the path, it fails. Not ideal. So what can we do? Well, let's just do a validate path. Oh, damn. Who would have guessed that somebody needs to validate a path? This validation rule does not exist. There is no validate path. Which is a curious oversight when it comes to this particular case. I believe validate path would have been a reasonable one to provide, but at some point we try to validate something that there is no built-in validation for. So we reach the time where we access validate script. A validate script allows us to specify a custom testing logic. In this case, I'm just going to test the path. $_ is the current item. In this case, in the case of validate script, we do the path validation of that. Do that again, and yeah, this is a perfectly correct answer. The validation script here for the value ftemp demo 3 did not return a result of true. Determine why the validation script failed and then try the command again. This is a perfectly precise error message. It's also 100% useless. So Let's do that again. Open curly brace, 0 closing curly brace means insert the first value, which in this particular context means, again, the current item, the path that you are validating. Isn't that nice? It worked. Much better error message. Now, Andrew, do you know the catch about that one?
What's the catch?
Oh, it's a glorious catch. I need to switch context a little bit and try this again. This error message attribute for the validate script came with PowerShell 6. The built-in Windows PowerShell does not have a provision for an error message property on validate script.
I did not know that.
Well, now I know. I've been trying to keep this basic, but there's one shameless plug coming in. There's with the PowerShell module PS Framework, one of my PowerShell modules, there's something called a PSF validate script that doesn't care about PowerShell versions. We still get ugly red, but the original error message worked just fine. So PS Framework, once again, cheating all day long. But cheating is all fine, but let's do it with the default methods, because let's be honest, while I'm really, really proud about what will hit, and I believe this is something to be proud of, we also want to provide a solution for people who can't use it. So what we can do is the following. Now, if the path exists, I return true. Return ends the validation script with the result I write behind that. So if the path exists, all is fine. Otherwise, we throw an error message. And if we do that, that works. And that works. Last tuning from a user experience thing, the red error messages in Windows PowerShell, they're ugly and there's no way around them. What we can do is we can try to make it a bit more user-friendly by also providing a warning. By doing that, now we get those 2 lines. In PowerShell 7, you can argue whether the extra line is necessary or not. But if you go to Windows PowerShell, we now have a clearly highlighted warning instead of just a red blob of error. All right. Any questions on what we covered? Because
I think we covered them.
Excellent. Well, in that case, I'm gonna call it. I surprisingly only went 15 minutes over time. I think that's a new personal record.
You can blame me because I asked an extra question at the end there. But Fred, that was glorious, man. It was fun to see people who I know have written modules and things like that still learning things from your presentation today, along with a lot of beginners asking questions, connecting dots. So you got us all covered.
Well, always happy to. You know where to find me for a follow-up.
I think we might need one in the future. Little tool making 2.0. Well, thank you so much, Fred. Fred, people like this. I guess you'll be contributing this to your GitHub, and I will share a link along with this video.
It's going to be on GitHub. Yes, very happy to share that link for everybody to access.
Awesome. And this will be recorded, posted on YouTube, on the PDQ YouTube channel, along with all the other PowerShell Wednesdays. Thank you so much for joining us. Fred, It's been a pleasure as always. Everybody, we're here every single Wednesday at 2 p.m. Eastern on discord.gg/PDQ. And we may continue our little LinkedIn experiment with PowerShell Wednesdays being there as well. It's getting PowerShell everywhere. PowerShell podcast drops every single Monday. Been doing it for several years straight. A lot of episodes. Some of my favorites have been with you, Fred. So check those out if you haven't yet. And we will see you all next week. Fred, thank you so much.
Thank you for having me.
Awesome. Take care, everybody. If you're on Discord, I will be moving over to the chit chat channel here and we can continue the conversation. Take care, everybody.